In the previous video you can see that the mouse movement is pretty slow, and in this video I'm going to refactor the code to make it go faster. The main reason why it's slow is because each sensor takes 20 milliseconds to sample, and they're being done in order, like this one, this one, this one, this one, like top left, top right, side top, side bottom, so that's 80 milliseconds. But you could parallelize that by having each sensor be sampled as a separate thread, and then doing the math against that. So that's what I'll do. And also I'm just gonna organize the code more so it's not like a single file. So if we look at the old code, there's like 200 lines in one file, main. This can be broken out into like separate classes and using threads, have things running separately. So that's what I'll do. This code here does a lot in random places. Okay, so I've broken out the code. First thing I did was make a copy of the old code, top to bottom. That's why I'd feature parity. Oh, crap, wait a minute. I won't have this. And you can see now that the pattern I'm following is main has, software folder. Main is at the software level, and it has folders which are contextual. So there's 4 sensors, so each sensor is a instance, and main is like the orchestrator, so it knows which are the shutdown pins. So when you instantiate new time of flight sensors right here, which this is the class time of flight, you pass in the shutdown pin and the address, which that comes from over here when you're turning them on one by one, and you're assigning these addresses, which I think these are I²C, which I could find out right now actually. One sec, I'm gonna have to have 2 instances. So this is on the Pi here. It's still running the old code. I start that. Actually, it'll go through this file over here, top to bottom. You can see it turning on the sensors. That comes from the library code. Oh, and you can see right there, 02F, 02E, 02D. But what I was trying to see is if I do this. Yeah, so that's what it's doing. 2B, 2D, 2E, 2F. So that's the address you're setting. I'm not sure if this is 29 in hex. I thought these were 40s, but I think it makes sense to be in the 20s because there's an ASCII. I don't know. See, I'm bad at that. The base CS knowledge. But yeah, I mean 20 you'd think 29. But this is hexadecimal, yeah, 0 to... I used to be able to convert that by hand between binary and hex. Anyway, point is, yeah, so it does work that way. That's how you address them. They're individual. But, yeah. Let me just turn that off, it's not being used. Anyway, so yeah, pretty much I was trying to match feature parity while breaking them out into isolated things. You can see how main runs, when you initialize it, it starts these classes like mouse events, and that is where mostly it deals with Pi auto GUI calls. It's kind of nasty bound checking thing here. What's the other one? Mouse buttons. This is dealing with the little daughter board thing on the side. Let me pull an image of that real quick. Yeah, so this board right here, that's what this code is for. So like these are the pins. You can't see it here, but these purple ones, they're like high input lines. So you pull them down so their 0 is off. And then the 3.3 volt power here, when you click the button, it completes the circuit and it feeds 3.3 volts into the purple, the GPIO input pins. So that's what's happening here. And then there's a loop here is like checking if that's high or not. If it goes high, then you click the button. And these are threads, so they're able to run isolated. Like when you run main, these separate loops will be able to run on their own, which buttons has one, the sensor has one. The way this sensor works, it has this loop and it's self-limited, like there's no time sleep here. It's self-limited by the 20 millisecond sampling time, which comes from this. I think it's even possible to get to 8, but this one's just 20 at high speed. But yeah, so this is just updating its own value, like this range value here. And then when you're dealing with the actual runtime, you can see here like instantiate trackpad. Trackpad is what deals with the continuously sampling all sensors and averaging them and then calling the event, which again is pulled from this code here. I just moved it into contextual, classes, so it's easier to like know where stuff is. Oh, I gotta put this here. This may be an anti-pattern to reference main like that, but anyway. Yeah, so here you can see it's calling main mouse events, move mouse right. If you go to mouse events, move mouse, and passing in the parameter right. So then it'll do all that, and eventually if it passes, it'll call that. So now I just gotta verify this works. But yeah, so the main change is, other than like branching everything out or breaking everything out into separate files, the time of flight sensors run by themselves, and they run like in parallel. They're sampling at the same time, and then the trackpad stuff is just reading the values that are there when it runs its own loop. So yeah, now I'm just gonna check it and see that it works. Alright, so here it's running the new code. The cursor is all the way at the top left. I'm gonna bring it over here. I think it's way faster. Well, it should be like 4 times faster, but yeah. It's still going at 50 px pixels. Let's just go up. It's hard. Oh, there we go. Just up, just down, right only, left only, just up. Yeah. There's no proportionality still, but yeah. So here it's working. Code's broken out. It's faster. Yeah, so that's cool. I will actually start to like use this, the keyboard and the mouse. You can see, let me bring it down. The right click stuff still works. I don't have the, oh, I do. Interesting. Ah, yeah, we can see that having it on makes it start to move for some reason. But at least the state management is working. I could look into that, but it's not really a big deal. Alright, so here, the simple fix is I flip the states. Like, when the trackpad isn't on, the light goes on. I gotta fix that. It's too quick. So like technically the trackpad is off right now, but it's allowing measurements, because the light is on. And then if I turn it off, then the mouse doesn't move because it's not active. It's ignoring input on the... Everything else still works. You can right click, left click. Yeah. Alright, let me show that. Go down, turn it on. Oh man, it's like too fast. There we go, wait. Go down, right click, yeah. Off. Mouse doesn't move.